Alright, today, 5, 6 inequalities in one triangle. Okay, got a lot of examples to get through, so let's hit the ground running. Okay, no vocab, okay, just the comparison property of inequality. Okay, if A is equal to B plus C and C is greater than 0, well then A should be greater than B. That should make sense, okay? And this is in relation to a triangle. Right, primarily this one where we had A, this was B, and C is part of the exterior angle theorem, so we're going to use. Alright, if angle A is equal to B plus C, okay, then, and C is an angle, so it's bigger than 0, then A is bigger than B. That's how we're going to use it for today, for the most part. So, moving on. Okay, this is exactly what I was talking about. This is the corollary, okay, of the triangle exterior angle theorem, which states the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. Which we just talked about. That's what I was explaining to you guys when I was drawing on the board. So I'm going to go ahead and move on. All right, use the figure at the right. Why is angle 2 larger than angle 3? The measure of angle 2, which is right here, larger than the measure of angle 3. Well, they're not related, you guys, by that exterior angle theorem I just told you about. Right? I said, hey, this we're going to be using today. And now, first example, it doesn't look like we're going to use it because this is not. Don't make the mistake that this is an exterior angle to this triangle right here. The exterior angle would be this line extended, so it's not. But how can I still use that? Well, we know by the isosceles triangle theorem that angle 2, right? Angle 2 is equal to the measure of angle 1 because the sides opposite them are equal. Well, angle 1 is an exterior angle to angle 3, so these are remote interior angles for this. So, use the figure to the right. Why? Well, angle 1 is equal to angle 2, and angle 1, or angle 3, is a remote exterior, remote interior, sorry, for angle 1. That's our explanation. Angle 1, or angle 2 is equal to angle 1, angle 2 equal to angle 1 larger than angle 3. Based on the corollary of the exterior angle theorem we had on the other slide. Alright, why is the measure of angle 5 larger than the measure of angle C? Okay, so to do this one, okay, what do we know? We know that this angle is a remote angle for this triangle right here, this big one. Okay? Triangle, just so you guys can see the one I'm talking about because there's a lot there. Triangle A, C, D, so the whole big one here. So since triangle ACD, alright, since angle C is an interior, angle 5 is a remote angle, not angle 5, angle C, I keep saying remote, I keep saying interior, excuse me, exterior, I'm supposed to be saying interior, so angle C is a remote interior angle of triangle ACD, and angle 5 is an exterior 3 plus angle C is equal to angle 5. And since 3 is not is greater than 0, we know that 5 is going to be bigger. Alright, theorem 510. Erase this so you guys can see this. A lot of theorems today, basically one for every example, and we have 5 examples. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Okay? So XZ is the longest side, Y is the larger angle. 511 is the exact opposite of that, which we'll do, which simply says that if Y is the larger angle, then the side opposite of that is the longer side. So here, okay, a town park is triangular. A landscaper architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Well, we find the largest side, 105, 120, and 175. What angle is opposite the longer side, 175? This one right here that is formed by MLK and Valley Road. Which two streets? MLK Boulevard and Valley Road. And again, because this corner is opposite that longer side. I can't even tell if you guys can see the laser beam. Let me know. Alright, 511, we talked about it. It simply states that if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So if you know a big angle, if you have the larger angle, the one opposite that is the longest one. Okay? So, problem 3, using theorem 511. Which choice shows the sides triangle T, UV in order from shortest to largest, or shortest to longest? Well, first let's find out what this angle T is. Remember, 58 plus 62 plus X, which is angle T, equals 180. This is 120, plus X is 180, then X is 60. So the sides that are opposite the larger angles, the longer, the smallest one, this is the smallest angle, that means TV, the side opposite it, is the shortest side. So we're going to start with TV. Okay, followed by T is the next smallest, so UV. So it should be TV, UV. It's going to be A. Okay, it would not be that. UT. UT is the longest side. Okay, theorem 512. Sheets. Okay, the lengths of any two sides of a triangle, or the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Please note that it says greater and not greater than. So it can't be equal, it's got to be more than. Alright, so xy plus xz is greater than xz, yz plus xz is greater than xy, xz plus xy is larger than yz. We can use this to find if lengths are able to be, or three angled sides can actually, three measured sides can actually form a triangle. That's what we're going to use that for. So, can a triangle have side length? So the given side length, explain. 3, 7, and 8. Well, 3 plus 7, is that greater than 8? Yes. What about 3 plus 8? Is that greater than 7? Check. Check. And the last one is 8 plus 7 greater than 3. Yes, that checks out. So all of those work. So, yes. What's my explanation? That's my work. That's how we know. Okay? Can a triangle have side lengths with the given lengths? Explain. So, does this work? Well, what's 5 plus 10? Is 5 plus 10 greater than 15? No. That's why. Remember I said they can't be equal, it's got to be greater than. So 5 plus 10 is greater than or equal to 15, yes. but not greater than. So no. Okay, find possible side lengths. Okay, a triangle has side lengths of 4 inches and 7 inches. What is the range of possible lengths for the third side? So we're going to do this. We're basically going to say, hey, we're going to do this problem like, hey, can 4, 7, and x be possible lengths? We're going to find which lengths for x that it would work. So this is going to be a lot like example 4, except for we're just going to find the value for x. What do I mean by that? 4 plus 7 needs to be greater than x. So 11 needs to be bigger than x. You gotta do this 3 times, okay? 4 plus x needs to be greater than 7. Well, then x needs to be greater than 3. Subtract the 4 from both sides. Okay, and then we need to do 7 plus x needs to be greater than 4. If we subtract the 7, we get x greater than -3. We're not even going to use that. We should usually have one side that we don't use. Why? Because if it's the length of a side, it needs to be positive. So it needs to be 11 needs to be bigger than x, or x needs to be less than 11 but greater than 3. So we're going to say 3. It's going to be x needs to be between 3 and 11 for it to form a triangle. Alright? That's it, guys. Have a wonderful day.